Hello, everyone. Thank you for joining us today. My name is Alena. I'm a software engineer at Rancher Labs. Rancher is an open source product that natively supports and manages Kubernetes, Mesos, and Swarm clusters. And here I have Brian Scott, the Walt Disney Company, one of our favorite Kubernetes users. And today we're going to talk about automating infrastructure deployment for Kubernetes. But first, we want to start with a short demo. A trailer, actually, something that Disney does for its presentations.
The world is coming undone. Imperial flags reign across the galaxy.
Can you be trusted without your shackles?
Let's just get this over with, shall we?
We've a mission for you. A major weapons test is imminent. We need to know how to destroy it.
If you're really doing this, I want to help.
Good.
Good. I've been recruiting for the rebellion for a long time.
We destroyed our home. I fight the Empire now.
I fear nothing. All is as the Force wills it.
The captain says you are a friend. I will not kill you.
Thanks. There isn't much time. Every day they grow stronger.
There is a 97.6% chance of failure. He means well.
This is our chance to make a real difference. Are you with me?
All the way.
We try to make the rest of our presentation as fun as this preview. So, Kubernetes. We all know Kubernetes is awesome. It automates your application deployment. It provides the DNS and Service Discovery for the services. It monitors the application health, and it recovers it on the fly. And it also provides the easy way to upgrade your application. So, but who does the same for Kubernetes cluster? Because if you think of it, Kubernetes system cluster is nothing else but a set of services. They talk to each other, that they have a database, and their health has to be monitored, and the upgrades should be handled the same way. There's many great tools in the market that provide all that. The kubeadm, Ansible, KOps, Bootkube, Terraform, and there's my favorite source, Kelsey Hightower. Thanks a lot to him for his docs and demos. His article, Kubernetes the Hard Way, actually makes it very easy to understand the internals behind the application cluster deployment. And all of these tools, they kind of try to solve the same set of challenges. And the biggest of them is probably the cloud infrastructure management. Because to run your Kubernetes cluster, you first have to provision the hosts, whether it's a bare metal or somewhere in the cloud. And then you have to set up a networking so the hosts can talk to each other. Then the DNS and Service Discoveries for Kubernetes system stack services to talk to each other. Then, again, somebody has to monitor the Kubernetes system cluster services and do the Kubernetes cluster upgrade. Kubernetes is the most popular orchestration platform for Rancher users, and we really focused on making the Kubernetes deployments and upgrades very easy for the users. And we started with laying the foundation. We wanted everything, like the networking, the DNS, the storage drivers, to work cross-cloud. And we didn't want to maintain the different set of scripts for AWS, GCE, DigitalOcean. We wanted the experience for the user to be cloud agnostic. So the user comes, He picks the AWS cloud, deploys his Kubernetes cluster. And when he decides, okay, I want to switch to some other cloud, the experience shouldn't be any different. And the other interesting thing is, like, I've spoken to some people today, and they're saying, okay, we want to just go straight to the Kubernetes application deployment. We don't want to deal with all the setups. Like, we don't want to learn about how to set Kubernetes. We want to just focus on the application deployments in Kubernetes. And that's something where in Rancher we makes it easy for the user. And I want to talk a little bit about Rancher architecture. So as you can see here, you register your hardware with Rancher, whether it's a bare metal or virtual machine in the cloud, and we build the infrastructure services on top of that. All the infrastructure services are containerized. In Rancher, we don't think of a container as the extra layer on top of the storage networking stack. We think that container redefines all the layers, and everything should be deployed in the container. So we run load balancer in the container, networking, then storage, database, DNS. So once this infrastructure services layer is set, we deploy the application orchestration platform. Whether it's a Kubernetes, Swarm, and Mesos, it's all containerized and built with just one click. So, and then after we containerize and deploy these two layers, a user can come and actually start deploying his applications. And the application management is not something that we do. We delegate it to the orchestration provider of the user choice. Kubernetes, Swarm, Mesos, up to you. So where do we start? The user starts with building his deployment template. So first he picks the orchestration, because based on orchestration, there are going to be different set of networking and storage drivers. So let's say he picked Kubernetes. We enable all the framework services on in the cluster to manage the Kubernetes system services, like the Rancher health check. That microservice will manage the Kubernetes system services health and recover them if they go south. And then the Rancher DNS, it provides the internal DNS for Kubernetes system services to talk to each other. And then we have a Rancher metadata, it's like EC2 style metadata that any service in Kubernetes cluster can access. After the framework services are picked, user is presented with one of the CNI drivers. So the default one is the Rancher IPsec. There's an overlay network that you can set up like cross clouds. And then we have Calico, VXLAN, and Weave. Our goal is to support all the CNI drivers that come with Kubernetes, and we are working on extending this set. After CNI driver is picked, there's time to pick a storage driver. So it's either Rancher EFS or X-Ray, which actually can be deployed as a flex volume plugin for Kubernetes. And again, we are working on adding more pluggable storage drivers to the Kubernetes setup. Once all this is picked, the template gets deployed with just one click. So here you can see all our choices: orchestration Kubernetes, the framework services, the networking. And here's the scheduling. Scheduling is actually, it's not the scheduler for Kubernetes application, it's rather the scheduler for a Kubernetes system stack. Besides building the Kubernetes deployment template, we also let user to pick the orchestration for the Kubernetes cluster deployment. So we have three popular choices. One is a standalone. It's when your Kubernetes system services, etcd, control plane, and user applications get deployed on a single host. Like let's say you want to QA something really quick, and you don't care about the resiliency and stability. So you go with this choice. Then there is a setup where you can aggregate your etcd and control plane on one set of hosts and user applications on another set of hosts. It is better, it's more resilient, but there's like potential performance issue with the etcd and control plane components. And then there's a third option is the resilient separate planes. It's high performance because etcd and Kubernetes API server and other control services are deployed on different set of hosts, and the user application is on the third set of hosts. This is production ready, tested by our customers. So once your Kubernetes cluster is up and running, we monitor its health all the time. So you shouldn't really see like red and yellow colors on this picture. Everything should be green in a perfect world. But yeah, here you go. You see that one of the services became unhealthy. It means that it stopped reporting to the health check, and there's a degraded state. It means the container is dead and it has to be replaced. So we actually do very detailed reporting on what's going on with your service. Like you can say, okay, one of the containers went unhealthy and it has to be replaced. And then you see green colors back again in a matter of seconds. A little bit more about health checks in Rancher. We run health check agent on every host, and every container of the Kubernetes system service gets monitored by 3 agents deployed on 3 different hosts. And once considered unhealthy by all the 3 agents, the container gets redeployed. We also have a different health check strategies based on your application. So for example, the regular one, just replace the container. You shouldn't worry about anything, like if it's dead, it's going to be replaced. But when it comes to services like etcd, where maintaining the quorum is crucial, that's where recreate on quorum strategy is very useful. Don't recreate unless your quorum is maintained. Once your quorum is lost, just leave the application around, don't do anything, because you can mess with the etcd data. We leave it up to you to recover it. Maintaining health check for control plane services is relatively easy, but when it comes to etcd health check, that's when it gets really tricky. So to make your etcd cluster really reliable, we suggest that you have like 3 hosts in your setup. But again, like the quorum can be lost even in the most stable environments, like your network can go south or your host can go down. And it's very important to configure a backup, the remote backup, in case something like all the hosts go down. So in Rancher, we recover from majority of the etcd failures. We do the disaster recovery, and we also allow you to configure remote backups, and then you can restore from that backups if you lose all the hosts in your system. So let's say your Kubernetes cluster is up and running. It's functioning well. It's being health check monitored and recovered as it goes. But there's always time where you want new features, new Kubernetes features, or bug fixes. And Kubernetes is pretty good with its release processes. Like the releases happen really fast. And we, in Rancher, we follow Kubernetes release and test every major and almost every minor release. Once tested, we publish the new template to our infrastructure catalog. And the users who have the Kubernetes deployments, they get a notification. Okay, you have a choice to upgrade to the latest Kubernetes version. It's optional. You can go with your older version. And if you decide to upgrade, you can upgrade with just 1 click. You pick your desired template to upgrade to, and Rancher will perform the rolling upgrade for you. It's better to see once than to hear 100 times, so we're going to move to the demo. All right. So first I want to demo the Rancher server setup. Sorry, it's really small. We wouldn't be a container company if we didn't deploy Rancher in the container itself. So to set up a Rancher server, it really does take just 1 click. You can set it up on any host where you have Docker installed, in any cloud. All right. All right, so it is coming up. Once it's up, it's going to be available on the port 8080 by default. Okay, so it's still coming up. It takes some time. It does deploy the MySQL database. It does deploy a bunch of microservices inside the container. And one of them is a Rancher. Here you go. Yeah. It takes some time. Yeah, it's loading all the components. Here you go. It should be ready now. Nice. Welcome to Rancher. So you have a choice whether you want to allow to collect anonymous stats. I'm just gonna disable this option for now. Got it. All right. So here is the Rancher UI, and the first thing you start with is with building your environment template and creating an environment. So what is environment in Rancher? Environment is an abstract concept that lets you group resources, that lets you group the hosts, that actually allows you to pick the orchestration platform for your environment, and all the infrastructure services that I mentioned earlier. Let's start with building the template. All right, so here you provide a name, Kubernetes latest. So here's all the orchestration choices that we give to you. Cuddle is a built-in orchestration platform in Rancher, and we actually use the Cuddle orchestration platform to orchestrate the Kubernetes system services. But for now, I'm just going to choose Kubernetes here. And here's a set of services that you can enable in your environment template. The external DNS, the networking. I'm just going to go with Rancher IPsec for now. And then the storage, and all the framework services. And also, I forgot to mention here, for the Kubernetes itself, you can pick what version of the Kubernetes you want. I'm just going to go with 1.4 so I can demo the upgrades later. Come on, okay, here you go. And a bunch of settings below that are used by each city, whether you want to enable backups and what is going to be your backup creation period and retention period. And then you click configure. All right. And if you go back to the manage environment, you can see all the environment templates right here. And any of them can be used when you add a new environment. So I'm adding a new environment. I'm going to name it Kubernetes. And I'm going to pick my Kubernetes template. And here you can see all the choices that you've made earlier: orchestration, framework, networking. You can also enable access control for your cluster. It can be like we support various access control modes. It can be a GitHub or LDAP or anything else. I'm just going to go without the access control for now. So once I click create, so here's my Kubernetes environment, and I can choose it here. But nothing is going to happen yet, just because this environment doesn't have any hosts. So we have to add a host. At least one is fine. So I go to the infrastructure page, and here I have an option. So you have an option whether you want a Rancher to provision the host for you, or you can register the host yourself by copying this command and executing it on any virtual machine or bare metal host of your choice. I think I'll go with a DigitalOcean. I'm going to provision a couple of hosts. Here we go. Demo. I'm gonna start with 3 hosts, and just any option that you would choose if you deploy it to the host in the DigitalOcean UI. I'm just going to choose Ubuntu, and I'm just going to click on create. It takes some time to provision the host. Like you have to start up the virtual machines, then it has to install Docker and install Rancher agent on them. And only after your infrastructure is configured, only then we start deploying the infrastructure services and the Kubernetes system cluster. So just to save the time, I'm going to switch to existing environment where I already have Kubernetes system cluster up and running. So I pick the Kubernetes option. I go to the infrastructure stack. And that's the place where I see all the infrastructure services that I picked earlier: DNS, health check, IPsec. And here's my Kubernetes system cluster. And you can see there's upgrade available option just because I've chosen the not the latest version of the Kubernetes to deploy from. And here you can actually see the graph of your Kubernetes application. So you can see the etcd, the Kubernetes API server, and all other components talking to the Kubernetes API. Everything is green, everything works so far. You can also see the template version of the Kubernetes cluster. We tried to avoid introducing a new configuration language for configuring the Kubernetes system cluster, so we went with the standard Docker Compose. So here is just regular Docker commands, plus some scheduling labels that we use to orchestrate the Kubernetes system cluster. If you go back, I'm just going to test an HA really quick. I'm going to do it by killing one controller manager container. There you go. Please load. Oops. Okay, so it is loaded. I'm just going to delete it right here and see what's going to happen here. So here immediately, oops, the service went unhealthy. And I got switched from the So what is initializing state? So we treat the containers like the startup process. We divide into two pieces. One is the Docker state, which is like running or stopped. And then there's the application state, because the Docker running doesn't mean that your application is up. Your application is up only when it starts listening to a specific port that health check is checking against. Only then we consider the service as active. And yeah, you can see the details of any service in your cluster. Like you can see the controller manager container, the IP address assigned to it. You can see the ports. You can see the log. This is a service log. You can see everything that happened to your service, like it went unhealthy, it got recovered. And then, if you click on the container, you will actually see the live stats of the controller manager container. All right, so if you go back to the infrastructure stacks, okay, upgrade available. Let's try the upgrade. So here, you can pick, okay, I'm going to pick the 145 because that's the latest. I'm just going to upgrade my Kubernetes cluster. Okay, so it starts with upgrading the API server. And you can see that the bunch of services, like ingress controller, goes unhealthy because it talks to the API server. Now the connection is lost for a second. It's going to be recovered really soon. There we go. Okay, so it's still upgrading. All right. Maybe refresh will help. It might take a bit longer just because it's downloading the new Kubernetes image to the host, but it shouldn't take a lot of time. I hope I'm not having a failing demo or a controller manager container is stuck in starting state. You can actually, let's see. Okay, so it's back. I can view its logs. I can see that it connected to the Kubernetes API server secure port successfully. So it should be green again. If I go back to the infrastructure stacks, okay, so it's still spinning. Okay, scheduler. What's going on with scheduler? Let's debug it. Okay, still starting. Okay, so it shows host as unknown. It means that it probably failed to schedule by some reason. Hopefully it will recover. Okay, here we go, it's back. My demo almost didn't fail. All right. Okay, so now everything is upgraded and up to date. And you actually have a choice. What if you change your mind and you really don't want a 145, you want to go back to 144? You can roll back. You can roll back. Or if you decide to go forward and you don't care about 144 anymore, you just say finish upgrade. And what's going to happen, we're going to kill all the old containers. Here we go. All right, so that's pretty much it from my side. I'm going to hand presentation over to Brian. Brian is going to demo the real application deployment in Rancher Kubernetes stack. You wanna connect your laptop? Okay.
I don't need the audio. I'm not going to show another video. Yeah.
All right.
All right, hey guys. So I'm Brian. I'll kind of go into intro a little bit in just a bit. So as you know, Disney's a very large organization with many different silos and companies underneath it. We're so far the biggest media company out there with a pretty big brand to kind of keep up. So with that, we have many different teams within Disney, all doing different things. So we literally like use almost every orchestration framework out there. And it's actually pretty good because we get a lot of feedback from both external and internal teams. So I'm going to kind of quickly show a quick intro or a quick demo of a app deployment. So again, I support both Walt Disney Studios and Imagineering. So I have an embedded team embedded in both of these segments, and our job is to assist that business unit with whatever their hosting needs are. So we literally embed ourselves with their devs, with their product teams to ensure that their applications are running in whatever infrastructure that they choose. So again, some of our challenges, right, is the infrastructure setup of Kubernetes, because we are a multi-cloud as well as on-prem. RBAC access, so again, we do have to have strict rules around which members can access what, which LDAP groups have access to which environments, especially for QA and dev teams. And then we have to be able to be like multi-tenant as well as a multi-cloud. Within Walt Disney Studios, we have 30 different dev teams that we have to support. And we have to deploy our infrastructure across both Amazon, Google, and on-prem, which is basically like Cloud Stack and OpenStack. And again, we have to be as self-service as possible because we are a small team of 5 within studios servicing 30 different teams. We have to be able to provide as much self-service and automation as possible out to our various teams. So again, right now we've been on Rancher for about, I would say, 6 to 8 months. We have since then we have about roughly 60 applications running within Rancher, all Polyglot applications. So Node.js, Java Spring, Go, Node.js, you name it, it's probably in there. The 2 main orchestrations that we've chose is Cattle and Kubernetes. And then again, we're across 3 different types of clouds. So we are able to scale our applications across any infrastructure that we seem fit. 2 of our major applications that we are running within Kubernetes is DisneyMoviesAnywhere.com. If you haven't tried it out, basically if you buy a Disney movie in, let's say, iTunes, that entitlement automatically flows into Amazon and or Google Play. So it allows you to buy the movie once, you get access to it almost anywhere. And again, we just launched the Doctor Strange. This was one of the applications that we launched within Rancher. We literally got the code Sunday night and had to be live for an announcement that following morning. So with that, I'll go into a quick demo. So this is the Rancher infrastructure that I spun up. DigitalOcean was very nice enough to give me some nodes to kind of play with. So I went ahead and launched a 5-node cluster. So this cluster is pre-running with Kubernetes already on it. If we go ahead and we go to deployments, you can see that everything's all zeroed out. We have a predefined stack already here that I deployed via the catalog. So I'm going to go ahead and blow that away real quick. So let's go to services, and we're just going to blow away. Actually, no, I should probably make sure that the replication controllers are actually offline. Yeah, because otherwise they'll bring everything right back up. It's like you can't kill anything in Kubernetes.
Did you make the font larger?
Yeah. Is that big enough? Cool. All right, so that's all gone. We're going to go back over to pods, and we're going to delete these pods. Let's get rid of these. Who needs WordPress anyway? Get rid of this. Okay, so that should be going away. No application controllers. except for the Kubernetes one, no replica sets, and no deployments. Let's go ahead and go to the catalog. Oh, my session timed out. Okay, so we're back. We're going to go back to the catalog again. We're going to scroll down to our WordPress, click View. Again, we're going to pick like 1.0. Service port is 80. We're going to go ahead and launch that. So as you can see now, we have application stack. It already launched MySQL, which is pending, and our web front ends are pending, and the host IP is already here. So obviously, if I had any type of DNS hosted with like DNS Simple or something, I'll go ahead and add this to my DNS, and the site will be live. So we're going to go ahead and let that bake for a little bit. Well, let's go ahead and deploy our own application. So I have my own application here. So if I go into configs, I have a service and a deployment. So we're going to go ahead and deploy this out, create, Wi-Fi. Come on, Wi-Fi. There we go. Never do a demo on hotel Wi-Fi. All right, so if we go back to deployments, we can see that my microbot's here. Let's go ahead and see what IP it currently has. So we're gonna go back over here to services, and I can see that my microbot is running on this port. So let's go ahead, you know what? We're gonna go ahead and do a downgrade. This is actually V2 of this particular application. So I'm gonna go over here to deployments, and we're gonna edit this right on the fly here. So I'm gonna go ahead and bring him down to V1, save it. And then as you can see here, we go over to controllers, pods. You can see that it went ahead and spun up new pods. It's gonna go ahead and kill off the old pods. So now if we go back here to do a refresh, it's still doing its upgrade. Pods take a second to go away. Go ahead and refresh. Come on, pods, go away. There we go. So now it's back to V1. And then if we want to go ahead and bring this back up to V2, again, we can always do it via like kube control, but I'm just going to go ahead and show you through the UI. And we're going to go ahead and bring this back up to the V2. Again, as far as hosts, you can see I have 5 hosts running here. I have both the Kubernetes stack deployed on here, as well as my application, and as well as WordPress. So if you guys want to see like the WordPress stack, we can go back to the application controllers. Oops, sorry. Sets. Where is it? Where's it? Services. There we go. And we're gonna go ahead and click on this. Here's the WordPress site. We're gonna go ahead and click next. Give it a test. Admin. We'll go ahead and copy this. Install WordPress. Oh, it didn't like the email address. Log in. Admin. And now we have our WordPress site. So we have 2 applications now deployed to our Kubernetes cluster via both the catalog and via kube control. So again, you still get that same interaction like using kube control. You don't have to really change your workflow. Again, we have a full solid pipeline, so we use Jenkins for almost everything. So once a developer does a git commit to either GitLab and or GitHub, Jenkins takes over, compiles those containers, pushes it up to our registry, then it goes ahead and it scans. It does a security scan of those container images to make sure that there's no vulnerabilities, because if there is, it stops the build. And then those containers get deployed into Rancher using Rancher.cli. So that's our full pipeline for literally every single application that we deploy in here. So the same app gets treated the same way. Every app gets scanned in the exact same fashion. And then we're actually also populating some of our applications into the catalog. So if a developer needs access to go ahead and deploy a dev environment or a predefined Elk stack into an environment for their logs, they can go ahead and do that. And everything's pretty much all self-service. So from an operations perspective, we're technically just platform maintainers. So we just maintain the platform and assist in onboarding those dev teams into onboarding their applications into Rancher. It usually all starts from Git, so we literally just give them a template like skeleton of what they need via a Git repo, and all from there they can get fully started. They don't even need to access Jenkins to get added into the pipeline. We use like Jenkins files, Docker Compose file, and a Rancher Compose file, and they can literally just onboard their application without having to access any of our existing tools. So it's full self-service, and we've been able to move pretty fast. Again, we have 60 apps already in there, and we've been, I would say, any new site or any new application that comes online does get put into containers. We don't hardly use the old methods of deploying your apps onto VMs. We still have a number of .NET applications that we're trying to figure out what to do with. So again, we're waiting until Microsoft and Docker kind of solve that problem for us, and then hopefully we can give that a try. Any questions?
Does Rancher have a command line interface?
It does. Yeah, we recently added the Rancher command line.
So how does Rancher server proxy the queue control commands to the actual master?
Well, I didn't show that.
Yeah.
Actually.
You want to show it?
Yeah, so I didn't show you guys this. Once you get like Kubernetes deployed, you can go here and generate the config for your local laptop if you want to use like kube control on like your local machine, or use it in Jenkins, or you can just go ahead and use this and go ahead and run the same commands right from the browser.
So what's going on there once you get the config? It's pointing to the server.
So we have a small microservice called WebSocket Proxy. It actually authorizes your requests and then just sends them to the API server once authorized. All the authorization is done on the Rancher side, but we are thinking about integrating with Kubernetes native authorization components by implementing the external provider.
What about requests coming from inside the cluster? Can they go to Kubernetes API server or your WebSocket?
It is actually going to the Kubernetes API server, and it can use like a service account or whatever you want that Kubernetes supports.
So it goes around your authorization.
We are working on integrating with the Kubernetes authorization.
Anything else?
Recently, how do you guys do the nodes coming in and out?
So like for example, so if we're within Amazon, we use the Amazon Autoscaling Groups, where we pass in a user data script into the node, and it automatically bootstraps it based on a predefined image that we have that's Disney approved, and then we go ahead and just bootstrap it with the Rancher agent, and then it just shows up within Rancher for that particular tenant. If it's not within Amazon, then we utilize a Terraform for those build outs. I will be pushing out my Terraform config out to my GitHub to allow you guys, if you guys want to use it to stand up Rancher as well as a Kubernetes within my DigitalOcean. I'll be publishing that right after this talk.
Any?
The catalog, can I populate the catalog with any image, or does it have to be any specific standard?
No specific. It's any image that any format that Kubernetes supports. It's a replication controller YAML, service YAML. So you just publish it to the catalog, and you can actually, if you click on this Add Catalog, you can add your custom Git repo catalog just for your users, and you can publish applications there. We also accept the user applications to our community catalog, and in the future we are planning to integrate with Helm.
Is the Kubernetes version modified in Rancher, or is it
We actually, that's a good question. So we started with maintaining our own fork of Kubernetes just because our network was kind of embedded and hard-coded. Then at some point, we moved the Rancher network into the CNI plugin. So there is no real reason for us to maintain the fork anymore. And we are currently in a process of upstreaming our Rancher cloud provider. So it's going to be just the Kubernetes official version.
Can you have multiple Kubernetes clusters, or one per Rancher installation?
It's one per Rancher environment. So if you go to the environments, Yes, here you go, manage environments. You can add a new environment here. And yes, it's going to be a different Kubernetes cluster. Or it can
Okay,
be as
I'll
well
do-
like Mesos
I'll do a
cluster
new one.
or anything.
So I'll do test
Yeah, sure.
2, and then we'll pick Kubernetes. Go ahead
And you have an access control enabled.
Yeah, I do have access control. So we're going to go ahead and do create. I'm going to switch over to this environment. You can see that I have no host. I'm going to do add host. I'm going to go ahead and go to DigitalOcean. I'm going to go ahead and open up, I believe, here, where is my, nope, don't have it, there we go, here's my DO token. We're going to grab this token, go back, paste the token in here, configure droplet. I'm going to say I want 5 servers called node. We're going to put this in San Francisco 1, and we're going to enable private networking, do create. And now it's going to go ahead and create the cluster.
Yeah, takes a bit of time.
Yeah, but at least
Yeah.
the process is the same.
So, and in Rancher, we are investing a lot into our integration with Kubernetes, and we have like 2 major features coming in. One is like we are going to start working on the Kubernetes federated control plane and integrating it with our UI. And we're gonna make our DNS more pluggable because today Rancher internal DNS is the default choice. We're gonna add Sky DNS as one more plugin. The same for load balancer. Like today, when you configure ingress, we create a Rancher load balancer that is backed up by HA proxy that runs to the container. And we're gonna add more providers like Traffic, Nginx. It's all again pluggable model. You can choose what you want for your ingress, and it's all gonna be deployed like cross clouds, and it's gonna balance your applications cross clouds too.
Anything else? Cool.
Well, thank you for attending
Thank
the
you, guys.
session.